And now for something completely different. I'm going to introduce looping in C#. And to introduce looping, I'm going to introduce the while loop. So consider this example here. I have a number counter. As soon as we open the software, it's saying to the user, welcome to the number counter. Please enter a number between 1 and 3. So let's run the application. And when I enter the number 3, for example, it counts to the number I input. So 1, 2, 3. If I enter the number 2, then it will count to number 2. And this is represented by these series of if and else if statements. So if the user enters 2, it just outputs 1, 2, 3, 1, 2, 3. So it counts to the number that the user enters. However, consider if we want to modify this application and ask the user for a number between 1 and 1000, for example. Now, how we would represent this with if statements, for each number, we would have this whole block. So if we have the number 4, then we're going to add another else if statement here, put in the number 4, then add another line here where we count to number 4. But if we go all the way to 1000, then this is going to be huge. The file size of our software will be huge. It will be really slow to run. So how do we solve this problem? Well, we can represent all of this logic here by using a loop. And we're going to use a while loop. So let me write out the while loop format so you can see. So just like the if statement, it looks quite similar, look. So consider the if statement, we have a condition. If the condition evaluates to true, then this line of code is executed one time. If the condition is false, it goes to the next else if statement and checks this condition. If that's true, it executes this code block once. However, with a while loop, if this condition is true, then it will keep repeating the contents here. So if I put console write line is 1 here, if this evaluates to true, and then it will just keep repeating this over and over and over until this evaluates to false. So that is how a while loop works in principle. So let's take a look at our example and how we can sort of modify our application to do all of this if logic here in one single while loop. So let's delete all of that. So what I want to do is I want this while loop to keep looping, 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 and outputting the number up to the number that we input. So this is the user's number that they're going to enter, and we want the while loop to keep looping till this number is reached. Okay, so how do we do that? So I'm going to introduce a new variable, and I'm going to call it counter. And I'm going to initialize it to 1. And what counter will be, this is the number that's going to keep incrementing. So 1, 2, 3, all the way up to the number that the user gives us. And what I want to do is output counter to the screen. So every time this while loop loops, I want to output the value of counter. It starts at 1, and then I want to increment counter by 1 each time. So what I could do is counter equals itself plus 1. So counter has the value of 1, but now I want it to equal itself, which is 1, and then add 1 to it. So now after this, counter will equal 2. And if it runs again, counter will equal 3, 4, etc. Now anytime you add 1 to a variable, you can do it this way, or you can do it this way. Just like that. This plus plus adds 1 to the current value, and that's just a shorthand way of typing this. It's exactly the same thing. It doesn't work with 2, only 1. And if you want to decrement it by 1, you use negative, negative, and that will subtract 1 from its value. But we just want to add 1. So every time this while loop loops, it's going to output counter, so 1. It's going to add 1 to it, and then it's going to go back to the start, check the condition. If it's still true, it's going to execute these 2 lines of code again. So that's how the while loop works. It's going to keep looping. But now we need a condition. And the condition should evaluate to true until it gets to whatever the user entered, and then it needs to escape from the while loop and carry on with the rest of the software. So what condition can we put in here to make this true? Well, we want to count to the user's number, including the user's number. So what we want to do is say while the counter is less than the user's number, then repeat this code. However, we want to include the user's number as well when it finishes counting. So it'll be less than or equal to. So let's just run this application real quick so we can take a look at this. So now enter a number between 1 and 1000. So let's type in number 7, for example, and press enter. You can see here it counts all the way to 7 from number 1. And that's essentially how a while loop works here. If we run the application again and type in 1000, it counts all the way to 1000 and then stops at 1000. So you can see with only, not much code at all, we can replicate all of those if and else if statements in a very simple while loop such as this one. So just so we're 100% clear, the software runs, it takes the number from the user, counter is initialized to 1. So this is now 1. So while 1 is less than or equal to whatever number the user put in here. Let's say the user typed in 44. So while 1 is less than or equal to 44, continue this code execution. So output counter to the screen, which will be 1, and then increase counter by 1. So now this is going to equal 2. So now counter equals 2. Yes, it's still less than or equal to 44. So again, continue. Now counter equals 3. It's still less than 44. So keep continuing this. Once counter equals 45, well, 45 is not less than or equal to 44. So what happens is it breaks out of here, jumps to here, and continues with the rest of the program. So that's essentially how the while loop works in C#. So I want to talk about something very important now we're introducing loops. So with while loops and any other loops we'll talk about in the future, there's a real danger of loops looping forever. They're just endless loops. And what happens when you get an endless loop is it will slowly eat up the memory in your system until either there's no memory left or something overflows or something catastrophic can happen. So this is a real danger here. Let's take a look at a very small example. So remember with if statements, there's a condition here, and if that evaluates to true, then it's going to run this code right here. So let me just write true in here. So what happens is, this is always true. It's always going to evaluate to true because I've written true there. Nothing is changing this in this code. And even Visual Studio has grayed this out because it knows it's just going to loop on this forever. So this is a very basic example. And of course this can be achieved by using variables that never reach their expected value, for example. So this will just continue to run forever. So if I run the program now, you can see it's just endlessly counting. And what's going to happen is either this number's going to grow too big for its container, or we're going to run out of memory on our system. But essentially this loop will just never end, and something will cause this program to crash. So it could be memory, it could be anything, and usually it's something very unexpected. So this is an example of where a loop can potentially loop forever. And this is quite common, and this is why we have to test software to make sure this doesn't happen. But now we're introducing loops. This is a real danger that can happen, and it's something you should be aware of moving forward.